Hello. In the last class, we have completed this one Venturi meter, na? Then let me explain you about first the application of Bernoulli's theorem. Airlift. That aircraft takes off, na? That thing we are going to discuss. See, in the aircraft, Haripriya, have you seen? Did you sit anytime beside those wings?
Could you come again, sir?
Did you sit sometimes means in the plane when you are sitting? That seat is there, no? That seat just beside you. You are able to watch the wings.
Yes, sir.
Did you look at the movement of the wings when it flies? Have you ever observed this?
Not really, sir, because they closed the window
Okay.
shields when you take off.
Actually, you did not see it. See what happens na, in the aircraft. What's the use of this wings? That I'll explain you. In the wings, you must have seen there are two very big fans, one on each side. They are known as propellers. What's the use of them? Air will be coming from this side and it will be flowing through the upper part and the downwards part. Okay, with the same velocity. And the propeller that is there, the fan, it actually sucks in the air. It increases the speed. Why it is important to increase the speed? Because let's say this portion is, here is the pressure, here this is a point 2, this is a point 1. Here obviously the pressure is P2, velocity is V2. Height difference is not much, so we can neglect it. Here pressure is P1, velocity is V1, say. Now, if we apply Bernoulli's theorem at the point 1 and 2, what we'll get? P1 plus half rho V1 square is equal to P2 plus half rho V2 square. Correct? Now what we need? P1 minus P2 is equal to half rho V2 square minus half rho V1 square. And to take off, usually the weight is mg. The weight of the aircraft is mg downwards. To take off, the ultimate force, that's P1 minus P2 into area, should be greater than mg, right? Correct?
Yes.
That's the ultimate requirement. Now, how do they do this one? To lift off, this is the requirement. When P1 minus P2 into A becomes greater than mg, this aircraft takes off. But how do they make P1 minus P2 that high quantity so that it overcomes the mg force? By using the velocity. Means P1 will be greater than P2 only when V2 should be greater than V1. How do they do it? They just, this back part, this back portion is actually movable. This back portion you are able to see now, it's movable. It can shift up, deflect down. When it has been deflected down like this, the velocity of air that's coming, it goes like this. So, and the velocity v2, it's actually like this moving. There is no restriction in the path of v2, but there is restriction in the path of v1. So like this, what will happen? V1 will become less than v2. Means v2 is greater than v1. Then p1 will be greater than p2. And it depends how much velocity you are increasing, how much v2 is greater than v1. How they achieve it, you must have seen whenever aircraft is about to take off, it starts with a very high acceleration, it gathers so much speed. And when it is at very high speed, you won't be able to observe it will just take off at some speed. But usually that speed is very high. So the aircraft speed is very high, so the opposite speed is high, opposite air speed is high, combined with the propeller trying to suck air with the high speed, so that these two speeds become, the velocity v2 becomes very high and v1 due to interruption becomes low. That's why they're able to maintain pressure difference p1 minus p2, and this, when p1 minus p2 into a becomes greater than mg, it takes off. Understood how the aircraft flies, takes off? Understood? Haripriya, Diva, did you understand, Diva, this one?
Yes, sir.
It's just an application, just the application of binomial theorem. The second one is cricket. In cricket, have you seen the bowler, fast bowler, they swing the ball? Do you know what's swinging the ball? Ball swing, in swing, out swing, those things. Haripriya, do you know something like this?
Yes, sir. The spin.
No, not spin. Spin is a different thing. Swing. Diva, you know what swing means? When
No, sir.
ball, when,
Cricket.
acha, you don't watch cricket. Actually, there are
No,
two.
it's in the motion like a spin, no, sir.
Motion is like spin, but
Yeah.
they
I don't
both
know
are.
what it is.
Actually, there are terms like in cricket, that's in swing or out swing. In swing, out swing, and it's for the ball. And it's spin. Spin is a different thing. There's spin is off spin, leg spin, like those things are there. But have you seen? There is this in swing is what, out swing is what. Let me tell you. Whenever these kinds of wickets are there, suppose 3 wickets are there. This wicket, na, and bails are there. This. No, cricketer is right-handed. Suppose. Why we say in swing ball? Suppose ball is this. It's moving at very high speed. The bowler has thrown, and this ball tends to come inside. After one bounce, it tends to come inside. This is known as in swing. But it's very high, it's high speed phenomena. And whenever this is done with this slow speed, it's off spin, leg spin. This is off spin. In high speed, when the ball tends to come inside, it's known as high in swing. And what is outswing? When at high speed, it tends to move out. Now you must be thinking, why sir is explaining us the cricket terms. I'm trying to explain you the phenomena of in-swing and outswing. Why it happens. One more thing I'll ask you. If you have ever seen cricket, have you observed this? Let me ask Kanishka. She must have seen. Kanishka, do you watch cricket? Hello, 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 hello. Kanishka, do you watch cricket? I think she's not able to hear me. So any one of you ever seen bowler is trying to sometimes the bowler trying to clean the ball with towel and all these things. They actually tend to rub balls with the towel they have or the handkerchief they have. Never. Haripriya, Diva, anyone?
Yes, sir.
Hmm. See, now I'll explain you the phenomena why this in-swing and out-swing occurs. Why do they actually rub the ball? This is the seam. Hmm. If they are rubbing it from this side, the left side, this tends to get smoother due to rubbing. This is rough. When the bowler has thrown the ball, the speed on this, the air will be coming like this on both the sides. Now here, because this part is rough, the velocity v1 on this part is velocity v2. The velocity v1 will be less than velocity v2. Okay. Now if we talk about the pressures, because they are at the same height, again we'll apply the Bernoulli's theorem. What will happen? P1 plus half rho v1 square will be equal to P2 plus half rho v2 square. Now when v1 is greater than v2, obviously P2 will be greater than P1, because half rho into v1 square minus v2 square according to this equation is equal to P2 minus P1. Correct? That means what? If this kind of thing is there, means when this part is smooth, this is rough, P2 is greater than P1. And because of this, what will happen? The effective force on the ball will be towards right, which will be P2 minus P1 into A. So what will happen? The ball will tend to move rightwards. Understood? And if the opposite case is there, this is smooth, this part is smooth, this is rough, the velocity on this part v1, the velocity on this part is v2, so v2 will be greater than v1. So when V2 is greater than V1, P1 will, array yaar, what is this? When V2 is greater than, again I'm doing the same thing. No. I'm explaining wrong. Here I have explained, I have taken the case, in the above case, if I have taken the case as when V2 was greater than V1. If V2 was greater than V1, then P1 will be greater than P2. In that case, smooth, this is rough. That means the ball will move towards the left. And now the second case, when V1 is less than V, I'm actually taking all the cases same. Now the first case was that. Now taking the second case, this is rough, this is smooth, this is V2, this is V1. In this case, V1 will be greater than V2. When V1 is greater than V2, P2 will be greater than P1. This is P2 and this is P1. So the effective force will be towards the right. And ball will tend to swing right. Now correct. Understood? Why singing is singing occurs to which side? Haripriya, Diva, Kanishka, tell me quickly. Spin is a different phenomena. It's just the application of Bernoulli's theorem. Spin is a different phenomena. In the spin, actually the baller, what baller does, you know? Baller actually, he holds the ball from the steam, and he knows if he wants to do the in swing for the bowler, then he will keep the smooth side to the left, so that, and then he'll throw it fastly. Then the ball will swing inside to the portion which is smooth, to that side swing. Like this, he throws the ball. But spin is a different phenomena. Doing the spin bowling is different one. In the spin, actually, the bowler rotates the ball, and when the bowler when this ball gets bounced on the surface, due to that rotation, it tends to move left. Understood this one?
Yes, sir.
Now let me tell you about the viscosity. These, if at all question is asked on this, they will ask you just a statement and reason based question. This one, not problem, they won't ask. Viscosity is like friction in fluid. Let's say it is a surface and which is in contact with some liquid. Then according to the viscosity, according to this phenomena, what happens? The fluid which is in contact with this moving surface with velocity v it is moving actually has the highest velocity. And now if we go down like this, the velocity keeps on decreasing. And how it decreases? If this is v plus dv, it will be v. And suppose the distance between them is y, dy, these two random points, then they say the force due to friction, the viscosity force, the force due to friction is given by F is equal to minus eta A dv by dy. What is eta? Eta is coefficient of viscosity. A is the area of contact. The area of contact, the area to which the liquid is in contact with the surface. dv by dy is known as velocity gradient. Velocity gradient. The velocity, if the bottom this surface was velocity v, the increase in velocity is v plus dv. So the dv is the increase in velocity, and increase in height is dy. So the velocity gradient is known as dv by dy. Understood? This is the force due to viscosity, the opposing force, the force with which one layer is opposed by the second layer. That force is given by minus eta A dv by dy. Clear? Let me give you one question on this. Try solving it.
It's 0.04 time.
0.04. It's 0.04 or
So
0.004.
do we have to convert twice?
No,
You get 4 into 10 to the power minus 2.
4 into 10 power minus 2. They are saying the answer is 0.004.
It's 4 into 10 to the power minus 3 then.
Hmm.
Then they've converted poise to decapoise.
What's the need of converting poise to decapoise?
Like poise is equal to 1 by 10th of decapoise. It's in SI units.
Hmm.
Poise is in CNG.
EGS, no?
Yes.
They have given everything in meter, 2 meter per second, 0.01. Correct. You will have to convert it because one poise is equal to that. One poise is equal to 0.1 Pascal second. You will have to convert it. Correct. This poise is a CGS unit. This is an SI unit. Correct you are. Then you will get the answer is 0.004. Otherwise you'll get 0.04. Correct answer is 0.004 Newton. Are you getting this answer?
Sir, I'm also getting this.
Kanishka, what about you? Okay, correct. You have to remember this is important. One poise, the CJ system and SI system units. Acha, let me tell you the next one. The next concept is terminal velocity. Have you seen actually what is this concept now? Whenever anything falls on the ground, means it's falling from very high, means it's at very high, from the very much height, it's falling from that. Then what happens whenever it is moving down, it has moved a very high distance. So what happens, it tries to acquire the spherical surface. That's why every drop of water that is falling down, it has the spherical shape. Correct? And even the ice falls na, that also has the spherical shape actually. Why? Because everything that falls down, if you see, if it is a cube, if you have a cube, then what will happen, because of the friction with the air or friction with the fluid under which it is falling, because of this friction, the friction tries to disintegrate it and tries to lower its area, surface area, so that it acquires, the body tries to acquire the minimum surface area. It tries to acquire the minimum surface area. And what's the minimum surface area? Minimum surface area is sphere. Correct? That's the thing. So what's this concept of terminal velocity? They say whenever the body falling down, it acquires the minimum surface area, that's the spherical shape. There appears a point at which the velocity of the body, spherical body, becomes almost constant. And this terminal velocity, that constant velocity that it acquires, this velocity is known as the terminal velocity.
Then we did this experiment in school. Made us drop the sphere in glycerine.
Glycerin is the most common one. How do we do the calculation for this? Whenever the body is falling down, its radius is r, suppose, visualize it as a sphere. Then what will be the forces acting upon this? One will be the force of buoyancy. That if suppose the density of the body is rho, and suppose the density, they keep rho sigma. And the density of fluid in which it is present is sigma, suppose. Let me write it. Sigma is the density of fluid. Rho is the density of body. Then what will be the force, buoyancy force, which will be acting on this? You know this one. Buoyancy force will be equal to V rho g. No, it's not V rho g, it's V sigma g. And there will be one more force, will be mg downwards. Mg you can write as V, its volume, into rho into g. Correct? There is one more force, that is the friction force, because of this air and all, that is given by the Stokes law. There is a Stokes law. What it says, the friction or the drag force, because of which the body tries to acquire the terminal velocity, that drag force is given by 6 pi eta r vt, where eta is again your coefficient of viscosity, r is the radius of the body, vt is the terminal velocity. So what are the forces acting on this? One is this drag force, one is buoyancy, it is moving down with the terminal velocity vt downwards. So drag force is negative force, which opposes the direction of motion. So these are all the forces. Now when we know vt is the constant velocity, that means what? When we'll be making the force equation, the vt is constant, so acceleration will be 0. So we can do net force is equal to 0 because acceleration is 0. So fb plus fd will be equal to mg. Now let's put the values. V sigma g plus, what is drag force, 6 pi eta r vt is equal to V into rho into g, and volume of sphere is what? 4 by 3 pi r cube. Let's put the value. 6 pi eta r vt is equal to 4 by 3 pi r cube into g rho minus sigma. Let's cancel things. pi gets cancelled, r gets cancelled with this r square. 2. So what expression you will be getting? Two r square into rho minus sigma into g by 9 eta. This should be the terminal velocity expression. We check 2r square rho minus sigma into g by 9 eta. Correct. So the terminal velocity expression is 2 into 2r square g into rho minus sigma by 9 eta. Everything you should remember. What's the r? R is the radius of the spherical body. G is acceleration due to gravity. Rho is the density of the body. And sigma is the density of fluid in which it is moving down, falling down. Eta is the coefficient of velocity. This is the expression of coefficient of viscosity. Sorry, the terminal velocity. Let me give you a question on this. See this, try to solve it.
So shouldn't G be in denominator?
Why?
Like 2GH. Oh, there's a G square.
There is a G on the other side also, na? 2 to the 4. So H should be equal to. The answer you must be getting is. We write in blue. H is equal to 2R power 4 by 81 into rho minus 1 by eta.
Option 3.
Option C.
3.
Option, what you are saying? A, B, C?
3, C.
C. Correct. I am also getting C only. What about you? Diva, Kanishka, you are getting the same answers?
Sir, I'm checking. I think I made a mistake.
Take it. Concept wise, you understood, na? How to solve this question? What about you, Kanishka? Some silly mistake you must have done. It's actually not difficult one, it's easy one. Now let me tell you about next concept. This terminal velocity, viscosity and all you have learned. Now I'll tell you one different concept whose its derivation is not there in your syllabus. It's not there in the JEE Main, JEE Advance also. But the concept is there. What's this Poiseuille's formula? Actually, this Poiseuille's formula is there for whenever a fluid is moving through a pipe. Suppose this kind of pipe is there, and you will find it series and parallel combination also. Achha, do you remember about series and parallel combination current? Diva, Haripriya, do you remember?
Sir.
No, sir.
Then it is difficult. Then I'll have to tell you everything. Because I thought I will be making this easier by relating it with series and parallel current.
So like I only remember the formulas, but not in detail.
Only few things you need to remember. See, Q, first let me tell you about this. Q is the volume of liquid coming out or going in, coming out per second. It's volume flow rate. One thing, correct? Volume flow rate. Q. We also know Q as rate of flow. A1, V1 that you used to do. Q is a rate of flow actually. And this value of Q, it is given as pi r power 4 delta P divided by 8 eta L. This formula you should remember for a flow through pipe. Flow of liquid through pipe. Now, what I wanted you to remember in series and parallel, current, electricity, what I think you will be remembering is whenever series combination is there in series, two resistors are added end to end. R1 and R2. And whenever we replace this with one equivalent resistance, we have this equivalent resistance as R1 plus R2. This, I know you know this one, correct? Now what I want you to know is, whenever in current electricity we study, I flows same through all the resistor. This you know or not? Not. I is same, but voltage drop is different. And this voltage V1 is given by what? V1 is equal to I into R1. V2 is equal to I into R2. This Ohm's law. Know this?
Yes, sir.
This much part you know, na? That is what is required. And when we talk about parallel, things will be different. What about parallel? This actually they have taught in 10th class, so you must be knowing it. Parallel means what? This type of combination will be there. You will remember, now you will understand why I am teaching you this. Because suddenly I have come from fluids to current electricity. In this, what will happen between these 2 points? The voltage remains same. Means here V is same across each resistor, but current is different, because if current I is coming, I1 goes through it, I2 goes through it, I comes out. Now V is same, but in this current is different. Now if we replace it with some resistance R equivalent, voltage across it will be V. Here voltage will be V1 plus V2. This R equivalent is given by 1 by R equivalent is equal to 1 by R1 plus 1 by R2. There is a derivation also, but I won't teach you that derivation. It's not required right now. Only this thing you need to remember about parallel and series, current electricity. This you remember or not?
Yes, sir. This much I remember.
Good, very good. Now coming to our fluids. In our fluids, what we say, this pressure difference is equivalent to voltage difference V. First thing. And resistance is also there. And this Q, rate of flow, is equated with current I. This similarity, this comparison you need to understand. Okay. Now since I said Q is equal to pi r power 4 delta P by 8 pi r power 4 delta P by 8 eta L, I can write this as delta P divided by 8 eta L by pi r power 4. It's similar to, because delta P is equated with V, voltage, this should be equated with R, because Q is I. Okay. So in fluid, when delta P is V, Q is I, then resistance R will be equated with 8 eta L by pi r power 4. Able to understand with this what I'm doing? Till now you understood or not? Don't worry, I'll give you questions also. Achha, 1 minute is only remaining. Now I'll give you two concepts. One is pipes in series. Let me continue in the next class. So A is pipes in series, B is pipes in parallel. What is this diagram? One pipe is there, another pipe is there. Suppose this is of length L1, this is of length L2. Pressure across this is delta P1. Pressure across this is delta P2. This is a series combination. The radius of this is R1. Radius of this is R2. Now, in this total pressure difference, delta P across these two will be equal to what? Delta P is equal to delta P1 plus delta P2. Because delta P is actually equated with voltage. Flow rate will remain same. Whatever Q is going inside, Q will come outside. Now in this, what relation we can write? Q is equal to delta P1 by R1 is equal to delta P2 by R2. It's like V by R1. Current is flowing same. V1 by R1 or V2 is equal to V2 by R2. Correct? Where R1 will be what? 8 eta L1 by pi R1 power 4. R2 is equal to 8 eta L2 by pi R2 power 4. Are you able to relate or not? Parallel case I will tell you in the next class.
Yes, sir, I understood.
Able to relate, na? Pressure is to be related with the voltage, Q with the current, because in the series current remains same, so Q will remain same. Same amount of flow will be there from this left and from the right tube, same, but only Q is there, but it's V by R1. Whenever we do like this, na, this resistance voltage across this resistance is R1, R2 voltage is V2, so current is flowing I, so I we write as V1 by R1 is equal to V2 by R2, like that. This is series case. Parallel case we'll discuss in next class, and then I'll give you the questions also on this. Then we'll move on to surface tension and all. Okay, let's end it.